So now we'll talk about the work, and specifically the work done by a constant force. We'll talk about varying forces a little bit later. So the work done by constant force is equal to the product of the magnitude of the displacement times the component of the force parallel to the displacement. That's in words. When we write that out, we write it like this. The work, which is a capital W, is equal to the force parallel, okay, times the displacement. All right? So what do we need? So how does this work? So say we have a box here. And on that box we apply some force at some angle theta. So here's our force, there's our angle theta. And that box, through the use of this force, that box moves a distance down, some distance d. Okay? Now, when we say the force parallel, we mean the component of the force that's in the direction of the displacement. So we can take the component of this force that's in the direction of the displacement, and to get this we use F cosine theta. Okay, that gives us our force parallel. That's the work equals the force parallel, F cosine theta, times the displacement d. Okay, in words that says the same thing here. And in general, this is the formula we'll be using. The work equals Fd cosine theta. So let's take a look at some of the cases here. If d is equal to 0, now this means that our displacement is equal to 0. So there is no motion. For example, if you push up against a wall, right, you're applying a force, but your displacement of the wall is equal to 0. Okay? And in that case, right, our d is equal to 0, then our work is also equal to 0. Now another example of this, if you're holding a book, right, you're not moving it or anything, you're just holding it. Your muscles are doing, it feels like your muscles are doing work, but that's because the way your muscles work, you have to do work to make them stay contracted. So it feels like you're doing work, but in the physics sense of it, since the displacement is equal to 0, our work also equals 0. Now you have another case. What if our theta equals 90 degrees? So in this case, let's say you're holding the book and you're just walking with it. Okay, you're walking with a constant velocity, so we're not worrying about accelerating the book or decelerating the book. We're just moving with the book. Now, in this case, our force is pointing, the force using to hold up the book is pointing up, and that's equaling the force going down, mg, and your displacement is in your direction of motion. Okay? But since the force is perpendicular to the displacement, our cosine theta now equals 0, and our work will then again be equal to 0. Right? Our force is not in the direction of the displacement. No component of the force is in the direction of the displacement. Now you can look up here, even in our first example, we have a component of the force that's in the other direction. Let's see if I can do it here. We have a component of the force in this direction, right? Now this direction, the component of the force in this direction, is perpendicular to our direction d, or our displacement direction. So that part of the force does 0 work. Okay? So those are the cases where theta equals 90 degrees. Now, when we have a bunch of different forces acting on the same object, the total work that is done is the algebraic sum of the work done by each force. Since work is a scalar, we can just add them up. So let's take an example of our box here. we have three forces on it, F1, F2, F3, and F1 is at some angle, and F3 is at some other angle. So if we're calculating the work then, the work from force 1 is F1 d cosine theta. The work from force 2 is F2 times d. Since we're parallel to it, it's the cosine of 0 degrees, which is 1. In F3, we get the work caused by force 3 is F3 d cosine theta. Now, when we want to find the total work done, we can just sum these up. So the total work done, capital W here, is work 1 plus work 2 plus work 3. Okay? So when we're working with scalars, we can just add them together. We don't have to worry about their vectors, even though we had to use that in this example to find out each of these works in the parallel direction. Okay?